In this tutorial, you'll learn how to identify the domain and range of a function from ordered pairs, a table, a mapping, a graph. Let's get started. First of all, the domain is the set of all the input values, or the x-coordinates, for the independent variable in a given relation. So in this list of ordered pairs here, all of the first values, known as the x-coordinates, are considered the domain. -2, 3, -7, and 6. When you list your domain, you use these fancy braces and commas to separate the values. You start from the lowest or the least value in the group, and you progress up to the greatest value. There are 4 ordered pairs. There are 4 different unique x values or inputs, but if there was a repeat, you do not list it. So if the domain is the input, that must mean that the range is the output. The range is the set of all the output values, all the y-coordinates, for the dependent variable in a given relation. Notice in this relation, you have an output of 3, 4, -1, and again another 4. So when we list our values from least to greatest, we don't repeat that 4 2 times. You can express a relation as a set of ordered pairs, a table, a graph, or a mapping, and you could be asked to identify the domain or the range from any of these types. So let's take a look at how we would convert them from one format to the other. So here with our ordered pairs, we can put them in the table usually exactly how you see them in this group. So you might list it in the order that it's written, 2, -2, 5, and -1, with the output or the y value being listed in the second column. You can simply take those ordered pairs or the table and plot those points on this graph. 2, 5, -2, 3, 5, -2, and -1, -2. In a mapping, you don't repeat any of your input or output values. So if I have a 2, a -2, a 5, and a -1, but for my range here, I would have a 5, a 3, a -2, and another -2. So I don't write it. Then when I draw my arrows from my inputs to my outputs, I can see how the domain maps to the range. Down here, I've listed some braces already so that I can list my values separately. I'm going to take a look at the table because for me, or the mapping, that's the quickest way for me to identify my domain and range. Again, I start from the least and go up to the greatest with no repeats. I think I accidentally wrote the wrong number there. -2, -1, +2, and 5. There we go. The range from least to greatest would be -2, then 3, then 5. And that's how you identify the values. You can practice trying this on your own. Pause the video and see if you can correctly format this set of relations. Let's take a look and see how you did. All right. Let's move on to a separate question you can be asked. This is an actual regions question where you're given a function and its rule, and you are given 3 domain values. If they ask you what the range of the function is, you simply take each of these inputs and put them into the equation or the function. You can do it mathematically yourself. So what is the output if the input is -1? What is the output if the input is 0? And what is the output if the input is 5? So you could calculate those yourself, or you could use a graphing calculator. When you use a graphing calculator, you simply put your function into the y equals button, 2x - 3, and you take a look at the table of values. And from there, you can find the range or the outputs. So I will arrow up one time and see if the domain is -1, the range would be -5. Then I can move my cursor down to 0. If the input is 0, the output is -3. And if I come down here to 5, I can see that it's 7. So the range for this particular domain of -1, 0, and 5, the range would be -5, -3, and 7. And that's how you would find the range if you're given an equation. Now there's no way that you can find the range unless you're given a domain. So the domain has to be given to you, and then you can find the range. All right. Next we're going to work on finding the domain and the range from a graph. This one's a little more tricky. When you're trying to determine the range, you scan your pencil from left to right across the graph and identify any or all of the x values in which you would be touching as you're scanning. So if I were to take a straight line here and I were to be scanning from left to right, I would be touching a lot of points, and actually this is quite important because it means that the graph keeps going. So not only would I be touching all of these values here, right? So if I was touching here, and here, and here, and here, and here, and here, and in between all here and here and here, that is an infinite amount of values. But the domain is how far to the left and how far to the right the graph goes. So if you see those arrows, that means it's going to keep going and going and going and going. So there's a couple of ways you can write your answer. You can use inequality notation. You could use interval notation. So the inequality notation here would be that it goes from -infinity to +infinity. And the domain is always the x value. So there would have to be an x in the middle of that inequality statement. Now if you want to use interval notation, you could, but remember that infinity signs always get parentheses. Now, there's one other special answer you could give here, and that's because the range is from -infinity to +infinity, which would be all the real numbers. So sometimes we write that phrase, and instead of writing the word real, we write this double bar R. So you can say all real numbers for this situation as well. Now the range is when you scan your pencil up and down. So we're looking to see how far up the graph goes, and as I'm moving up, I see that the graph has arrows that point in that direction. But as I move my eyes down the graph, it actually stops right here and doesn't go any further. Now I know it stops there, and the graph actually touches that point. So that means that the lowest the graph can go is -2. The highest the graph can go is infinity. And the range is all of your y values. Now because it touches the -2, I put an equal to sign. Infinity you can never be equal to, so I just put a less than sign. If I wanted to use interval notation, I would use a bracket, and infinity always gets a parentheses. All right, question number 2 is actually a bit easier because there are no arrows. The only way you can get an infinity sign in your answer is if there's an arrow pointing in some direction. For this one, this circle is finite, or means it has a measurable amount of space. It does not extend forever in any direction. So if I look at my left and right sides of the circle, those are the limits, right? So -3 is as far as it goes to the left, +3 is as far as it goes to the right. And the fact that the circle actually is a solid line is important because that means it literally touches those areas. Don't forget the domain is always the x values. If you want to use interval notation, you can. Now the range is how far up and down you go. Again, this range actually touches the -3 and the +3. So the lowest value is -3, the highest value is +3, and the range is always the y. Because the line is solid, we use equal to signs. And again, you could use interval notation if you like. Now this one's a special case. Both the domain and the range are the same, and that doesn't usually happen. All right, let's take a look at a few more. Do you think you're getting the hang of it? Why don't you pause the video and give these a try? Okay, let's see how you did. So I'm going to work these 4 out with you. Now you have a couple of answers you can give for number 3. It looks when I am going to the left and going to the right that I do have arrows extending in both directions. So if you'd like, you could say all real numbers. Or you could use your negative infinity and positive infinity signs, but all real numbers is generally the most common answer. The same is true for the range here. I know it seems like the arrows are pointing to the right and pointing to the left, but they're actually moving gradually up and up and up, and down and down and down. And because of that, the range would also be all real numbers. All right, question number 4 does have a limit. This is a quadratic, and this parabola has a maximum point up here, and then it turns and starts coming back down again. So the range does have a limit, but it looks like the graph is moving constantly more to the left and forever more to the right. So I know it looks like it's going down, but each time it's moving a little bit to the left as well. So this domain is, again, all real numbers. That's a tricky one. But the range goes all the way up to 5, but then it goes down forever and ever and ever. So this range, you could say that it is y is less than or equal to 5. Or you could say that its lowest value is negative infinity, and its highest value is positive 5. And since the graph is a solid line, that's why I use a bracket here. All right, this number 5 is kind of like our circle. It is a completely finite shape with no arrows in any directions. So I'm definitely not going to have all real numbers as an answer this time. So it looks like my farthest left is -1. My farthest right is 1, 2, 3, 4, 5. So -1 is my minimum there. Positive 5, and always an X in the middle. The square is a solid line circle, and you could also use interval notation. The range looks like it goes down as low as -3 and as high as +3. And this one gets a Y in the middle. And again, you can use interval notation. All right, number 6 is back to the arrows. Looks like the arrows go down and left, right? And up and right. So this one is also all reals, or from negative infinity to positive infinity. Again, you can write it in English, or you can write it in math. All right, are you starting to get the hang of it now? I'm not going to work out this next set, but I will give you the solutions. So pause the video now and give it a go. All right, ready to see how you did? Number 9 and 10 are kind of tricky, so we might need to talk about them. You'll notice that this is a vertical line, which means it doesn't go any movement to the left and it doesn't go any movement to the right. It constantly stays on the value of 2. That's why the domain is this one single sentence. You cannot use interval notation because it is not an interval. It is not a space or a selection of numbers between 2 values. The same is true for the range on question number 10. The graph makes no movement up or down. It constantly stays at 4. All right, give it one last try. Now pause the movie and really try your best. All right, you ready to check your answers? I hope you got them right. That concludes our video on how to find the domain and range.